Welcome to Click Academic. This is lesson 9 on the series Differential and Integral Calculus. We'll be discussing techniques of differentiation in this lesson. Out of techniques of differentiation, the first one is chain rule. But before we start this now, we've talked about first principle differentiation. We see how that works. So for chain rule now, to understand chain rule, we have to see what first principle differentiation led us to. So what first principle differentiation led us to, it's simplified differentiation for us. Meaning, if I have x squared now, how we differentiated it for the first time, in that the first example we did, if y is equal to this, then my dy dx is just simply going to be 2x. We've seen that already. So what we notice is a pattern emerged, because if you can look at this now, you see that what happened is my power multiplied my coefficient. I brought the power down, that is, to the front, 2x, then I subtracted 1 from my power, so it's x power 1. Also, if I have x cubed, then dy dx of x cubed is going to be, I'm going to bring my 3 down, 3x, subtract 1 from my power, so this is going to be 3x squared. Also, finally, if you have something like this, 2x squared, I'm going to bring my 2 down, multiplying the coefficient is going to be 4x, 2 minus 1, power 1, so just 4x. So this is how we differentiate, and this is what first principle led us to. So having this now, we can differentiate functions like this. But what if we're given a function inside another function? Because chain rule is also called the function of a function rule. So if what we're given functions that like encapsulate another function. So picture something like this. I have x squared plus 3x squared. This is not, dy dx is not equals to 2 into x squared plus 3x. It's not the same thing. We can illustrate this if we expand this and differentiate. So you will see that we're not going to get something like this. So how do we use chain rule now? It says if we have, you see, if you can see that this is a function, then we now apply another operation to it, this squared. So a function and another function inside it. So what we do with this chain rule is we simplify. Always what we try to do is we simplify it to the base case, meaning something like this. We are going to see a table of standard derivatives at the end of this video. So we will see how that works. So given something like this, x squared plus 3x squared, all squared that is, what we do is we try to simplify it to look something like what we have just differentiated earlier. So I'll say maybe let u, mind you we can use any letter for this. So we usually use u. So let u be this x squared plus 3x without the power. Because you can see that this is easily differentiable. It means that my y is equals to u squared. So differentiating u, du dx will be what? I bring my 2, subtract 1 from the power. Then I can do the same thing for this. This is power 1. 1 times 3 is just 3. X, 1 minus 1 is 0. So x raised to power 0 is 1. So this is just 3. 2x plus 3. So differentiating my y with respect to u, I bring down my power 2, subtract 1 from power 1. So this is 2 power 1. But my u is something. This is 2 into, my u is x squared plus 3x. So this is dy du. So chain rule says now dy dx is going to be equal to du dx times dy du, which is the same thing as du dx is 2x plus 3 into dy du is 2 into x squared plus 3x. So I can simplify this. This 2 will just multiply whatever is outside here. So I can just say 2 into 2x plus 3 times x squared plus 3x. So this is how we differentiate using chain rule. Thank you.